Hello everyone, I will give a tutorial about the LTSpice, how you can use it. First of all, for the schematic you need to click File and you need to press New Schematic, and you will see a new window about the schematic window which you will perform your in-lab assignments for the rest of the semester. Here we have a zoom options. You can zoom in and zoom out on schematic, and these are the important part of the screen. Like this is the wire, this is ground. You can label any net from there. You can put a resistor here, you can put a capacitor by selecting that, diode, and if you want to add a component like the operational amplifier, you need to click component. This is a move object and this is a drag. And another important thing is that there is a spice directive. Let's build first a voltage divider. For this we need to put two resistors. This is the first resistor, and whenever I press Ctrl with R, you can rotate any component, and I will put the second resistor like this. And in order to connect that, I need to select the wire, and I will put a connection between the two resistors, and I will create another wire here like this, and I need to put a ground like this. And last thing, I need a voltage source. For voltage source I need to click a component, and here we have a voltage selection. Then press OK and put a voltage source like this, and put a ground for the minus part, and put the wire. For the voltage divider I select the values like 5k ohm and 5k ohm. They are equal, and let's say that the voltage DC value is 15 volt. In order to read these operation points, you need to label the nets, like otherwise it will be so confusing. So that's why I select the label net. I put a way in for the input part, and I press label net again. I put V out for the output part. So now it's ready for the DC simulation. For the simulation types, we need to right click, and there is an edit simulation command. There are lots of sections. We will generally use the transient, AC analysis, DC sweep, and DC operational points. For this we need to just click DC operational points and press OK and put there. Now it's ready for the simulation. So whenever I click run, here we have a voltage value at the output 7.5 volt, and at the input it's 15 volt, and these are the current values. For the DC sweep simulation, I will change the circuit a little bit, like you did in the 5th week lab. I will put a diode, and we will see if the input voltage source like you did in the 5th week. Right click on the resistor, and let's change the resistance value as 1k like we did previously, and I press the delete, and I delete the resistor, second resistor. Instead of second resistor, I select the diode, and I press Ctrl with R, and I put the diode. Now I can handle the last connection, and in order to say that it is our diode, we need to right click on that, like what I mean is our diode. It's 1N4148. Right click on the diode, and you can select pick new diode, and from there is a selection for 1N4148, and then press OK. For the DC sweep operation, we need to right click, and we need to select edit simulation command, and here we have a DC sweep, and name of the first source to sweep, the name of our first DC supply is the V1, so that's why I wrote it as a V1. And type of sweep, I select linear. start value is 0, stop value is 10, and increment is, let's say, 0.1. And then I press OK, and whenever I put there, as you see that this becomes a semicolon and this becomes dot. It means that it will not operate DC operating points no more. It will not simulate DC operating points. It will simulate this sweep value. So let's right click again and press run. Here we can see that it's a 0 volt to 10 volt, and here we can see that the Vout value. And if you want to see the current value like you did in the fifth lab, you need to click on the resistance and you will see that there is the current value. And if you want, you can also add a equation. Let's right click and add trace, and I select V in minus V out, then I press OK. Like maybe you remember, it is the diode voltage VD. And in order to delete any trace, you need to press a delete here and select V in and V out. Here we have a diode voltage, and here we have a current value on the diode. So if you want to simulate a sweep operation like this, you can use this environment. And the next thing, I will use the transient simulation. For transient simulation, I will perform the lab which you did in the second week. Instead of diode, we will use a capacitance here. But first of all, I need to change the resistance position. Resistance should be like this, and I delete the extra wire here. And instead of these resistors, I will use a capacitance here, and I will just move the ground and put the connection like this. And here, as a capacitance value, I will select a 47 nanofarad, and as an input voltage, I will create a square wave. That's why I click the right click and select the advanced. There is a pulse option here. Initial volt is 0 and on voltage is 5. It means that we have a 5 volt peak to peak. These are some 100 femtoseconds. These are some values, like you can think that they are just perfect. And let's say that the frequency of the pulse signal is a 500 Hz. That's why I put the values like this and press OK. Now I just want to create a transient simulation, so that's why right click, select edit simulation command, and here we have a selection transient, and let's select the stop time as a 20 microsecond. And whenever I put that, now this becomes a semicolon. So let's try to simulate it. And if you click the oscilloscope probe on the input part, it is just your input signal. And when you click the output, you will see that it's there is a capacitance trying to charge that, but since it's cannot be charged, that's why we see something like this. Now I will show you how you can perform the AC analysis. For AC analysis, we need to use operational amplifiers like you did in the fourth week lab. For the operational amplifiers, let's put some idle parts first, then I will show the whole things. Click the component, and here there is a selection for op amps, and we have a op amp 2. Then press OK and put the operational amplifier like this. And as you know, we need a 15 plus and minus 15 volt. We need to make sure that it's operating. So that's why click the component and go back to the first screen. Here we have a voltage source, and put one voltage source like this and the other voltage source like this. Make sure that you ground it to both negative sides. and the value of this one is 15 volt and the value of that one is minus 15 volt. Let's put a connection. And we need 3 different resistors. This is the first one, this is the second one, and this is the third one. I just performed your assignment, in-lab assignment, which you did in the 4th week, I guess. You have a gain, 10 gain as an inverting amplifier, and this one is 4.7k ohm. This one, the value of this one is the 5.6k, and the value of this one is 56k. Let's connect this like this, and we have a connection like this. And the last thing, we need to add a input source, so that's why I just click this one, copy this one, and I just also put a ground connection here. And this one should be not DC source, it should be a sine wave. That's why I select the advanced, and here sine wave, you can create any signal sine wave, but if you want to run transient wave, you need to add these values. But for AC analysis, we need to just add the AC amplitude as a 1 here. And the last thing is we need to edit simulation command again, and there's the AC analysis type of suite. We select octave and the number of points, let's say 10, and start frequency from 10 Hertz to, let's say, 100k Hertz, and I put like this. And the last thing is we need to make sure that this is our operational amplifier. So I mean that what I mean is we need to define these operational amplifiers as we used in our labs, LM741. So that's why I need to click OP here. Then I need to select .lib. First of all, I need to write .lib, and for the this is our LM741.lib, but you can put this directly on your folder, program files, LTSpice, lib. There is your LM741.lib. You can just select this one and put here, and you need to write LM741.lib. Press OK and put here. And the last thing, you need to write this one as a LM741 instead of op-amp2, and again we need to label as Vin here and Vout here. Now we are ready for the simulation. Let's run. And this is our input, it's 0 dB, and this is our output, it's 20 dB. Why it's 20 dB? Because we have a gain, 10 gain here, that's why it is 20 dB. If you have any question, you can send an email to me. That's all from our side as a tutorial. Make sure that you handle all the parts, and following weeks we will use the LTSpice as a in-lab as a part of in-lab assignments.